Good morning one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV 62 for 6th semester student. So lateral earth pressure of module 3 lecture class 2. Today we are discussing about Rankine's theory for cohesionless and cohesive soil and Kuhlmann's theory. So Rankine in the year 1857 developed a theory for lateral earth pressure. So with the backfill material or a dry cohesionless soil. The theory was later extended by Rezal in 1910 and Basel in the year 1950 to made application to the cohesive soil also. So there Rankine has used some assumptions. The assumptions is soil mass is semi-infinite homogeneous. In reality, no soil is homogeneous. It is a heterogeneous. If it is homogeneous, means soil should be purely sand, it should be purely clay, it should be purely silt. But if you take a lump of soil, it is a combination of sand, silt and clay or any two combinations, or it may have more than three combinations like gravel, etc. But we are assuming it as a homogeneous soil and dry and cohesionless soil. The ground surface is plane, which may be horizontal or it may be inclined. The back of the wall is vertical and smooth. The back yields about the base and thus satisfies the deformation condition of plastic equilibrium. The following are the cases of cohesionless backfill which will known to be considered. So I am considering here it is a 5 cases: dry and moist backfill with no surcharge, submerged backfill, backfill with uniform surcharge, backfill with sloping surcharge, and inclined backfill with surcharge. So consider first one, dry and moist surcharge. Let us consider this is a retaining wall and it is a retaining wall and a soil is retained behind that retaining wall. So now because of the backfill material, soil exerts some pressure on the retaining wall. That pressure is indicated as a triangular pressure distribution diagram. So let H will be the height of the retaining wall and the active earth pressure is given by Ka, that is active earth pressure coefficient, into gamma is density of soil into Z at any depth Z. If Z is equal to H, full height, then it becomes H. So Ka gamma into H is the pressure and it is acting on the retaining wall is given by half into Ka gamma into Z into half into base into height. Height is Z. So when Z is equal to H, then half into Ka into gamma into H square. It is acting at a height of H by 3 from the base. So this is the equation which gives the active earth pressure. So for dry and moist backfill with no surcharge. Second case, so submerged backfill. Whenever there is a water table up to a height H, then we can say it is a submerged backfill. When the submerged backfill is there, so this is retaining wall, this is backfill, water table is up to the top, means because of soil it exerts a one triangular pressure, because of water it exerts another triangular pressure. Therefore the two pressures should be taken into consideration. The base of the triangle, the pressure distribution triangle for soil alone is Ka into gamma dash into H, because it is submerged condition. Gamma submerged is equal to gamma sach minus gamma W, that we are all known it. And due to water pressure, gamma W into H, here we should not multiply Ka because the active earth pressure coefficient Ka is depending on angle of internal friction 1 minus sin phi by 1 plus sin phi. When we consider water, there is no angle of internal friction, therefore we should not multiply Ka. So or Kp in case of passive earth pressure condition. Now we have to calculate pressure. Pressure is the for triangular portion of the soil. The triangular portion of the soil is Pa1. For water pressure portion is Pa2. So P is equal to the total pressure. P is equal to Pa1 plus Pa2. So I can say like this. So Pa, which is equal to, so I am writing the equation, you please see the students, Pa1 plus Pa2. So now Pa1 plus Pa2, if I consider Pa1, it is half into Ka into gamma dash into H again into H, that is half into base into height plus half into gamma W into H plus H. So half into base into height. So at what distance it is acting? So it is acting at a distance of, that is the H by 3 from the base, because both are triangle. If it is other than triangle, then you have to take moment at any one point. If you are taking moment at any one point, PA into X is the height at which the PA is acting, which should be equal to PA1 into H by 3 plus PA2 into H by 3, or to calculate it. Then, so take out the X is equal to PA1 into H by 3 plus PA2 into H by 3 divided by PA. If you do it, you will get the distance at which the pressure is acting. I hope you understood this equation. Next, coming to the case 2, if the free water stands both the sides of a wall, so need to be considered. So then suppose if I am making a coffer dam construction. Coffer dam means it is a submerged dam. So both the sides of the coffer dam we have a water pressure. If that is the case, the pressure acting from left side to right side nullifies with the pressure acting from right side to left side. Therefore, we should not consider gamma W into H for our calculation. Then only earth pressure we have to consider, that is Ka gamma into H. Then your Pa value will become half into Ka gamma dash into H into H. At what distance it is acting? It is acting again at a distance of H by 3, because no other force is there. So this is the next thing. And next is coming to the case 3. If a backfill is partially submerged, that is the backfill is moist to the depth H1 and below H1 it is a submerged condition, then the lateral pressure intensity at the base of the wall is given by so Ka, that is, if you see, this is the height of the retaining wall. In the height of the retaining wall, water is not there at the ground level, that is at the top of the retaining wall. Water is available at a depth of H1. So that means from the bottom up to height H2 it is submerged. From the height H2 to top it is saturated. So whenever you have two cases, we should understand what is the angle of internal friction for H1 and angle of internal friction for H2. Suppose if angle of internal friction H1 and angle of internal friction for H2 is one and the same, then following equation we have to use it. So for this particular triangle, the base of the triangle is Ka gamma into H1, and this pressure from H1 onwards it falls on to the bottom of H2 as a rectangular force, that is Ka gamma H1 as it is, and the backfill pressure in this second, that is portion H2 is Ka gamma dash. Why it is gamma dash? Because it is submerged. Why it is gamma? This is the pressure will be Ka gamma H1 will act as just as a Q. Therefore, so we have taken entire Q into consideration, which is rectangle. Ka gamma dash into H2, and another water pressure triangle is gamma W into H2. As I said earlier, for water pressure there is no earth pressure coefficient. So now once you get all these things, then you have to calculate the combined effect of PA, active earth pressure. Combined effect of active earth pressure is given by PA1 is from H1 and rectangular portion PA2, third triangular portion PA3, fourth triangular portion PA4. So for each one, so you have to calculate. I will tell you for the first one, triangular portion, the PA1 value is equal to K half into base Ka gamma into H into H1, which is acting at a distance of H2 plus H by 3. Next, For second rectangular case, it is L into B Ka gamma H1 into H2, which is acting at a distance of h by 2 from the base. Next, plus triangular portion half into Ka gamma dash into H2 into h, half into base into height, which is acting at a distance of h by 3. Next, so triangular portion, even though it is not right angle triangle, we are assuming it as a right angle triangle, half into gamma w into h2 into h2, half into base into height, acting at a distance of h by 3. Now, the total pressure PA is equal to the pressure acting from the Ka gamma H1, the pressure acting from Ka gamma dash H2, Ka gamma dash H2, and gamma W H2, and the triangular portion. So now, if I take that is the summation of all the forces at the tip of the retaining wall, then PA into Y is equal to PA1 into H1 by 3 plus H2. Next, PA2 into H2 by 2 plus PA3 into H2 by 3 plus PA4 into H2 by 3. So if you equate it, you will get Y value. So this is how we can calculate for partially saturated soil. And if phi1 is not equal to phi2, then for this triangle Ka gamma H1 you have to take. If for this triangle Ka2, if that is the case Ka1, this will be Ka2, you have to consider it as Ka2 gamma H2. So as I said earlier, same thing I have written here. If it is different, say phi1 and phi2 respectively, then earth pressure coefficient are Ka1 and Ka2 for both the portions will be different as phi decreases, Ka increases. So the lateral earth pressure you have to consider Ka2 gamma H1, Ka2 gamma dash H2, Ka gamma WH2 you have to consider. Next, backfill with uniform structure. Suppose some apartment you are constructed on the top of the backfill, another side you have a retaining wall. Best example is ring road, we can see in Bangalore this type of structures. Then the apartment load we have to consider it as a Q, uniformly distributed load. If that is the case, how the pressure distribution diagram you have to write? So whatever Q is there, that will remain same. Therefore, a rectangle you have to write, that is Ka into Q, and remaining thing is same. If it is a dry means Ka gamma H. If it is saturated, again one more triangle gamma W and H2 you have to consider. Now when you are calculating the position of PA total, then the position of PA total is Ka half into Ka gamma H base into height, half into base into height, plus Ka into Q, that is base width, into height, So if you calculate it, so you will get the pressure, earth pressure. Okay. So then at what distance it is acting? If it is only triangle, it is h by 3. It is not triangle. Therefore, what we have to do? PA into Y is equal to, this I will consider it as PA1 and this I will consider it as PA2. So PA1 into h by 3 plus PA2 into h by 2. So Y is unknown. Calculate Y, you will get that distance. So this is the next one, backfill with uniform structure. Now passive earth pressure, Rankine's theory. As I said earlier, if a retaining wall moves towards the backfill, when it moves towards the backfill, then horizontal component force is higher. So in this case, the passive earth pressure, the plastic equilibrium of lateral earth pressure is the major principal stress, while the vertical pressure will be minor principal stress. So sigma, as I said earlier, when it has to move towards backfill means your sigma 1 should be equal to sigma h and sigma 3 should be equal to sigma 3. Minor principal stress will be vertical. If as long as minor vertical that is stress is major, active condition occurs. When the vertical stress is minor, passive condition can be expected. So consider sigma 1 is equal to sigma h, that is equal to pp, passive earth pressure condition. Sigma 3 is equal to sigma v, that is gamma into h. So value substitute in this equation. Let us consider element at a depth z from the top. Sigma h is equal to major principal stress, sigma 3 is equal to minor principal stress. From this stress relationship, we know that sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f. Sigma 1 is equal to sigma 3 tan square alpha f, and if you rearrange the equation, you will get kp. That is 1 plus sin phi divided by 1 minus sin phi. This is kp, 1 plus sin phi divided by 1 minus sin phi. So now earth pressure coefficient kp gamma into z is acting at the bottom at a distance of h by 3 from the base. So Coulomb's wedge theory, it is also known as wedge theory. Instead of considering the equilibrium of an element within the mass of material, Coulomb 1775 considered the equilibrium of the whole of the material supported by retaining wall when the wall is on the point of moving slightly away from the backfill. The wedge theory of earth pressure is based on the concept of sliding wedge, which is in turn off from the rest of the backfill on movement of the wall. In case of active earth pressure, the sliding wedge moves downward and outward. So one slip surface related to the intact backfill, and in case of passive earth pressure, the sliding wedge moves upward and inward direction. So Coulomb's wedge theory assumptions, he has done some assumptions before going for Coulomb's wedge theory. The assumptions are dry backfill, rupture surface is plane, sliding wedge act as a rigid body, position of direction of earth pressure is known. So this is a Coulomb's theory, and this is the backfill, sloping backfill A, that is D, which makes an angle beta, and the failure envelope that is BD will make an angle that is the phi. So now the wedge, the sliding wedge is WO, and this makes an angle that is theta with respect to inclined surface. So now let us see BD. Where is BD? This is B and D. BD shows a plane inclined at an angle of phi to the horizontal, at which the soil is expected to be in the absence of any lateral earth pressure. The line BD therefore is called as a natural sloping line, and the repose line or the phi line. AD, this is AD, is inclined at an angle beta to the horizontal and is called as a ground line or surcharge line. The plane BC, so is inclined at an angle psi, it termed to be terminated. So then the S line or the rupture plane or the slip line, and an angle that is omega is called as critical slip line. Okay. So now coming to the MCQ questions, Rankine is in 1857 developed a theory for lateral earth pressure with a backfill material as dry cohesionless soil. As it is true, option is A. Assumptions made by Rankine to calculate active earth pressure are only the soil mass is semi-infinite, homogeneous, cohesionless. Option B, it is false. Assumption made by Rankine to calculate active earth pressure are only the ground. It is also false. Options made by Rankine to calculate active earth pressure is backfill with vertical or smooth. It is false. The assumptions made by Rankine to calculate active earth pressure are only the backfill yields about the base and thus satisfy the deformation condition plastic economics. So one of the assumption, it is not a only assumption, therefore the option is B, it is false. So next is assumptions made by Rankine is all the four is quoted, that is true. Option is A. When the wall is at the point of moving outward, the active earth pressure equilibrium is established. S. Moving away from the retaining wall is active. So the option is A. Horizontal pressure in the is when the minimum principal stress, and the vertical pressure is the major principal stress in case of active earth pressure condition. That is true. Then it is true. So assuming that the soil is sufficiently for active condition to develop horizontal stresses, the depth is Z is equal to PA. That is also true. The assuming that the soil yields sufficiently for an active condition to develop horizontal depth, Z is PA. So that is true. So these are the list of references that we are done for preparation of this material. I take this opportunity to thank Department of Technical Education and Collegiate Education as well as students for giving me an opportunity to deliver this particular lecture. Thank you one and all. Students, if you have any doubt, you can ask in the next class. Thank you very much.